Numerical Computation, Chapter 10, Video 1. In this chapter, we will study two-point boundary value problems for ordinary differential equations, typically second-order differential equations. So we will be consider a second-order ODE in the following one. So y as a function of x is our unknown. And the second derivative of y is given as a function of x, of y, and y prime. And now we will be given boundary conditions instead. So the function is defined on the interval for x between a and b. And at a, the value of y is given to be alpha, and at b, the value of y is given as beta. Notice that this is very different from the initial value problem. The initial value problem with the initial conditions are all given at the same starting time if you think x is time. So there will be a starting time. We used to call it t0, for example, x0, and you will be given the value y at x0 and y prime at x0. Okay, so but here is different. One condition is at A and another condition is at B, and we are interested in finding solutions in between A and B. As to motivate our study, we begin by mentioning that such equations, they arise in many physical applications. For example, the modeling of an elastic string can be done by the following linear ODE. Second derivative of y, where y is the vertical displacement of an elastic string held in a horizontal position. So the y second derivative equals to k times y plus some number m times x and times x minus L. Here the L is the length of your string, and you will have boundary conditions at the two ends where you hold the string at a fixed point, in a fixed position. So y at 0 is 0, y at L is 0. So you hold it horizontally at the two ends, and then the string could vibrate in between. One may also have nonlinear equations. Here is just a random example. Say some equation like this, and you see this term is nonlinear in y prime, and this term is nonlinear in y. And you have boundary conditions, for example. So we will study two numerical methods for this type of problem. The first method is called shooting method. This is a method that's based on all the ODE solvers that we have developed so far and taking advantages of that. And the second one is the finite difference method, which has wide applications in solutions of differential equations, including ordinary differential equations, as well as partial differential equations, which will come towards the end. Well, I hope you're curious and excited, and we'll learn. I'll see you next time.